All right, so welcome everyone to this workshop. This is, I'm going to record this for people later as well, so I might make some comments for those not here with us now. My first point I want to make is I'm going to give, by and large, a technical perspective on a lot of this, but I'm trying to put my other two hats, which I definitely wear, in this as well. So it's going to be pretty comprehensive. So this is the agenda. We're going to talk about what Tonomy ID is, why build it, and then how does it work. After that, we're going to have a little break where we also have some questions, and then maybe people can go have a coffee or whatever. And then finish with who's it for, how do we make money, and what's next. My plan is that we do clarifying questions only during the two halves. And then there's a question time at the end of the first half and the end of the second half. There is a glossary that's in our Notion site now. You can find it by clicking here. I've sent everyone the pre-work, which is to understand public keys. That's this. And our existing commercial strategy. That's here. So without further ado, what is Tonomy ID? So it's an open source, user-friendly mobile app. It's also referred to as an identity wallet. So this is supposed to be a replacement of your wallet, a digital replacement. So it replaces what you currently use for your bank cards, passport, and driver's license to identify yourself. And then also, as in the case of bank cards, to authorize you to other services. It's much more than that, though. It extends your wallet to store any kind of data. This could be medical records, diplomas, properties. Basically, anything about you can live in this wallet as data, and then you can use that to share with other people. It's a way to access the internet. So it's one app that you can access all of these apps without having to put in your password. So you can just log into internet apps. These apps can be on the ecosystem that we're in, but they also can just be not in our ecosystem that we've deployed this to. So we might deploy this in Telos, but once we develop this feature, you can actually log into non-Telos apps as well. So it's a replacement for, it's the next generation of identity. And it's special because it replaces custodial identity with non-custodial identity, meaning that the person is in control of their data. There are previous editions of digital identity. The first big one was email password. Then we moved on to OAuth and OpenID Connect. You probably don't know what these are, but this is the evolution of internet identity. And we're up to what's called self-sovereign identity, the latest one. So it's really the next innovation in internet identity. And more than that, it's a new architecture for the internet. It starts to place user data directly and foremost in control of the user by putting it on their phone as the primary instead of on servers around the world. So it means that person with the data on their phone shares it directly with other people because they have it, they know what's happening to it. And that's different from when you have somebody custodian of it, you have to trust them to share it for you and trust them to verify it. This also takes away a huge single point of failure that exists in most identity systems, which have all of your identity data on their server. It creates a server-side risk. It creates a honeypot, which incentivizes people to want to hack those servers because it has all that identity information. Once you start putting all the identity information on everyone's phone, you get a decentralized identity system. And to hack somebody, you have to go and hack their phone one by one. You can't hack them all at once. It takes the incentives drastically down. You may still be able to hack somebody, but you can't hack everybody at once. So it's a massive improvement in identity, privacy, and ethics. And so the way we're going forward is we're building an iOS and Android app. We're doing this using what's called a cross-platform framework. That's React Native. So we write the code in React Native, and that deploys to both iOS and Android. And the reason we're doing this on a mobile and not building like a web wallet is because they're just much more secure devices. These operating systems, iOS and Android, are just much more secure, and people just have these, so it just makes a lot more sense for identity. What are we actually going to be creating in this process? So obviously, first and foremost, we're going to create the mobile wallet, the app. So this is something you can download from the Apple or Google app stores. But what we do to make that happen is we develop the mobile app software, right? This is open source. Anyone can go in. We've actually already created the repository already. So this is the React Native repository. We also create a whole bunch of supporting open source software. So stuff that hooks it all together for us to develop on, a demonstration application, some testing suites, a bunch of other open source software. We're also creating a software development kit. So this gets integrated and is used by our mobile app. So this is kind of like the business logic in our SDK. And then in the React Native app is where we have more like the user interface, what it looks like. And this SDK is used both by the mobile app, but it's also used by other developers to integrate and interact with our mobile app. So if I want to build an app that can ask for my date of birth from your Tonomy ID, I would use this SDK to interact with the mobile app. Likely along the way, we're also going to be contributing to other people's software as well, other people's open source software. This is because most importantly, we'll need to make our app work. We're probably going to need to develop a few of this, but it's also just very good publicity and good partnership. And lastly, we'll create a whole bunch of documentation, both in the form of our website, product websites, user manuals, and then, of course, the developer documentation as well of how it works and how you can run it, how you can set it up. A big design practice where we're definitely building into this is we're building modular software. And I'm going to show you a bit more about the architecture later. This is important because it first and foremost is the best practice to build it modular. You keep the functional code to do one thing apart from doing another thing. But also this allows us to componentize our application and apply for different grants for different components so that we can get lots of different funding sources. Last note here is currently I've put an MIT license on all of our open source software, and there is a task in our backlog to maybe have a bit of a better investigation on what license we want to use for our open source software. So why build it? Right, so we've been planning for quite some time, and we've applied to some grants, we're talking to some partners. To a fair extent, we're coming up against a chicken and egg problem. Because we have no product, we're not generating any validation that we can do what we say we do, we're not getting a reputation, people aren't interested, people aren't investing, and therefore we have no product. So it's a bit of a circle, so we just decided to build it and do the best we can for our first product. We're trying to keep it lean, mean, and minimum so that we don't put too much work in and can get something that's validatable and show some adoption. So that's a very general why we're doing it. Why are we building an identity app in particular? Because we're also building a DAO factory, a governance platform, and the governance platform is maybe the most important thing we're doing in terms of our big, hairy, audacious goal. But we're building the identity app first for a few reasons. The first big one is that identity is the first step that any user has to take to participate in an ecosystem. They have to have an account, and they have to be able to authorize as that account. And it's the first step they need to use any of the rest of our products. So Tonomy Governance, Tonomy DAO. So we do need this component. We're just in the middle here, Chris. So the second reason is it's got a lot of innovation in Tonomy ID, as we'll see. And that innovation is very good for grants, so getting some first equity-free investment. So lastly, as we've gone through in our commercial strategy process, we've decided we really want to go for a software as a service model in our second phase. And I'll be showing you a bit more about how that works in some later slides. But obviously, to have a software as a service, you need to have a product you can sell as a service. So that's what Tonomy ID will be. So this is currently what Tonomy is looking like at the moment. So right now we are building what's called the MVP, the minimum viable product. An MVP is a lean philosophy concept. It means build the minimum you need to prove your hypothesis about a product need in the market. So we want to do the minimum we can to prove that we're on the right track. And the tactic we decided is to build a transaction signer. That was in a previous discussion we had. So it just signs transactions on the blockchain. So that's the only thing our first MVP will do. The next feature, so we have a bunch of features here. None of them are necessarily in order after this first one. But this is my general idea at this point of an order. So we want to build a social recovery feature. That means you can recover your account if you lose your phone without having to depend on a third-party identity or recovery service. The next feature is single sign-on login, so SSO login. That means you can sign into internet applications. So I can use my ID app and I can sign into Netflix, or I can sign into something else. This does require, of course, that those apps support us as their sign-on method, but that's what this will allow them to do. Next feature is to sign documents, basically sign PDFs that you approve and agree to them. So putting a digital signature on them, as opposed to having to do, your stupid little import a JPEG with your signature, which doesn't really mean anything. This is a big feature that a lot of people are very interested in, basically proving that each person has one account. That's very important for democracies. Of course, you need one person, one account, but it's just good for accountability in many systems. Airbnb has these problems. All kinds of internet applications have this problem that they weren't solved properly and cheaply. Credential sharing, this is where you can sign data like your name, date of birth, medical records, and then share them directly peer-to-peer with people and have them validate it without relying on a third-party service. This is part of the self-sovereign identity movement that's going on. So communication, basically allow any Tonomy ID user to send a message to any other Tonomy ID user. And sorry, I need to go through that again. We want to build an admin panel. So this is for the ecosystem administrator to configure the identity product itself. They may want to, let's say, choose that users can create an identity with their email, or choose the branding on their app. Or we're not exactly sure what will be here yet, but it's for configuration by the ecosystem administrator. And lastly, and this is another product, it is to build our software as a service platform that allows people to click and deploy Tonomy ID and the required infrastructure to do that in one click, and then they can immediately use it. So these are all
clarification.
Yes.
This is all just about Tonomy ID. This is all just the timeline specific to.
Correct.
Okay.
Correct. So all of these are features of Tonomy ID. The admin panel will probably be a separate application, and the software as a service platform will be a separate application. The rest of these will be features of the one application, the Tonomy ID mobile app.
Okay, thanks.
And the software as a service and admin panels will be features of all of our other products as well. So they are kind of shared, but we need to build it for this product as well.
Okay.
Sorry, I had one more thing to say here. Each of these features here is applicable for grants. They're all quite innovative to different levels, and for different grants, it's probably better for different things here. because at the EU level, they may have solved some of these problems already, but not others. And at the crypto level, they may have solved some of these problems, but not others. So it's good to align when we're doing grad proposals on these kinds of features and what we can propose. So this is what's called lean philosophy. This is a lean cycle here. You start with creating an idea. You basically take a leap of faith with a hypothesis to build something. You create the MVP. And this is a really important step here. You measure how successful the MVP is relative to your hypothesis. With that insight, you can learn and, if necessary, pivot back on your idea and build again. It's definitely a cycle. It's not a linear process. There's a really good book. You can click on this link down here. It says Lean Startup Book. It really goes into all of this. There are also like 3-page summaries of this if you can't be bothered. And I do want to distinguish this from Scrum. Scrum is a process. It's our structure for our week. Lean is a philosophy of how we think about validating and building absolutely what's needed. So I did want to introduce you guys to this. And if you're not aware of it, please check out this book. So what does it actually look like? So we've already built a little demo that I can show you now. This is kind of what it's going to look and feel like. This is just one of the use cases, the single sign-on use case. So I'm here on Netflix, okay? It now has an option to sign in with Tonomy ID. I click on here. It goes to a login page with a QR code. Now I'm going to click here. And then I need to complete the login on my phone, right? So I go over to my phone. I'm here. I click scan. This is where I scan that QR code. And once I've done that correctly, it'll give me the login page. So this is where all of those different features will differ. Here, this is about single sign-on login. So it's about, do you want to log into Netflix? If we're signing a transaction, this screen would be different. It would say, do you want to sign this transaction? If the feature is about sharing credential, it would say, perhaps, do you want to share your identity data with Netflix? So there's a few different flow deviations here, but this is the general flow. What this app does is actually very basic. It just allows you to do all of those flows and signs data. So that is a very basic demo of what this is going to be doing. I think it'll probably look a bit more professional, but that's a general idea here. So how does it actually work? What's going on in this app? So I've asked you guys all to watch this video. This is the public keys part 2. So what's going on here in the app, right? We have this mobile app, and as we create our account, we're creating a master password, a PIN, and or fingerprints. We may be selecting some recovery buddies, and we may even connect a key card to our device that can authorize it from this hardware. All of these get transferred or turn into cryptographic material called a private key. So we take our password and we generate a private key from that, so that every time we use that password, it can generate the same private key. And what we do is we put the public key onto a blockchain network. So we send it from the app and say, hey, blockchain network, this is our key corresponding to our master password. And we want you to store this across the whole decentralized blockchain network. What this allows us to do is sign with different keys in our app. Okay, so we're going to have different keys, and each of these is actually a different security guarantee. If I sign with my master password, it's a proof of knowledge. It proves that I remember something. If I sign with my PIN, it proves that I am there with my phone at the time. If I have a key card, it proves that I have the key with me. All of these are different like balances between usability and security. I may put my key in a locker somewhere. So it's really not very useful for me to have it all the time, but it's very high security. So that's kind of one security balance. But a PIN is very easy. right? I just need to put in 4 digits and then I can sign something. So it's a very high usability, lower security. It's still very secure because this key never leaves the mobile app, but it's easier to use. So these will be different options for how we can sign data with. The public key, this is how we prove that we signed with the private key, okay? With that public key, I can verify any data and show that the private key must have signed it. Because that private key never left this device, it means this device had to have signed the data. And because this public key is stored on a decentralized network, there's no single point of failure. All of these blockchain nodes cryptographically audit in real time that all of these keys are up to date. So that means you just can't lose these keys. You can always prove that your private key is signing the correct data. There's an immutable history of these public keys, and you can always, like I said, verify that data. What we then do with this is we take various types of data and we sign them with it in the app. So we might take a transaction or a PDF document, and we send this to the app, and that app takes one of these keys here and it signs that data. Now you can basically put that data somewhere else, and they can go back to the blockchain, check the public key, and they can get the proof that the private key signed it. Because they know these private keys never left the device, and they know that perhaps because they check out our open source code, or because they read our documentation and believe us, and they believe us because other people have audited our open source code and know that it's the truth. So because they know that only this key could have signed it from the device, they know that we were there and we signed the document, or we signed the message that was sent to them, or we signed the app login, right? This makes it autonomous. It means we have full control of it. Nobody can take those keys out of the phone, right? Only we control it. So that means it's a sovereign autonomous account. Both of those words are synonymous, by the way. And that's also a very high security model, of course, because the only way to hack all of these keys is to hack every phone. So you can, perhaps there are ways to hack somebody's phone, but you only hack one. It takes away the honeypot security attack. It takes away the server-side risks of all kinds of nasty things hackers can do. It's also, of course, more private. These documents go to our phone and then can get sent directly to the person who wants to use it. It doesn't have to go through a server. I'm going to show you a little bit kind of how this looks like now. So this is a bit of a history of how internet identity has worked. So we're starting with Web 2, kind of where most of the internet is now. The way this is working is in our client app. This could be our mobile app or our web app that we're using. You generate a key, and this also, the exact same key gets stored in a database. It has to go through a server to get there that checks that the key makes sense. Now, every time you want to prove you are who you say you are, you sign something with that key, and you don't sign something, you send that key with the request every time, and the server checks that that key matches what's in the database, right? So it means that the same key is on this database, and all of your data is also in this database. It's a big, big pot of data. All the authentication secrets are there. This is kind of what, it's a bit simplified, but this is generally how most of the internet works. And it's insecure because if you hack that database, you get all of the secrets and all of the data. This is the model that Facebook and most of the internet's using now. So come in blockchain or Web3, and they basically made the upgrade. Everything now uses public-private key technology. So the client has the private key, and that's authorized, and the public key is put on the blockchain. And you can authorize privately, you can authorize autonomously from your client and sign something, and everyone can verify that only that private key could have signed it, so therefore only you signed the data. There is an issue with Web3, though, especially in public blockchains, is that there's no place to privately store your personal information. So if you have information about yourself, your name, your date of birth, your health records, there's no private place to put them here on these public blockchains. What some apps do very incorrectly is put that data on the blockchain, which is a terrible security and privacy breach for the individual. This is where self-sovereign identity came in. It saw this problem seen both here and here, and it decided to create a new standard. This standard is going through the World Wide Web Consortium, W3C. This is the consortium body made up mainly of the main browser providers, Google, Apple, Mozilla, and more, quite a lot of other bodies. These are the main ones. And they govern the internet standards like HTTP or TCP. They govern how all of this stuff works. And they've created a new standard called the DID method, DIDs, and verifiable credentials. This is part of what they called self-sovereign identity. So self-sovereign identity is at the base a set of new internet standards. And they created a standard that basically allows you to create this data, leave it in the client, and have it verifiably signed by this key in a standardized way so that anybody with the public key, which they can check on the blockchain, can always validate that data, and the data can stay sovereignly controlled in the client. So it's very cool technology. What's quite special about this, a few people have done it before, but nobody has really tried to achieve the level of interoperability that this has done. So by standardizing these data sources, these data structures, they make this data, so your identity data, usable across all of the internet in a very highly reusable way. And this is what we're trying to do with Tonomy ID as well. We want to use this standard to store the data in the client so that it's never sitting on a server or a database, and you can use any blockchain node to verify that it's correct. 2 slides left, and then we have a pause. So this is the general architecture. I'm not going to go deep into this now. We can go deep into it later with the technical team if you want. But basically, you can see here, this is our client. This is our React Native application with several subcomponents into it. This is the blockchain. We have several smart contracts on it to allow this to work. We are eventually going to have some microservices, not with the MVP, but with the future features. We need a few things to happen here. And then this, for example, could be our key card that you co-sign with or something. What's important to understand here is that we break down this architecture and our design into reusable components that we can claim to be innovative on, we can get grant money for, and that we can give a single function to and a single responsibility to, which is good engineering practice. All of this stuff here, except the blockchain, is JavaScript based, so that's our full tech stack. There's a few questions I just wanted to address here about accessibility. How is Tonomy ID going to work for people with disability and a few other edge cases? Okay, so I just wanted to go through these quickly and my current idea. In my opinion, all of these are future features that we're not going to build in the MVP. These can come out as we find the need for them, okay? But for the MVP, we're just going to try and prove we can do this minimum thing first. But with disability as well as children, what we can do is build in the concept of a digital guardian or a digital custodian. That means as a parent in my phone, I can switch to the role of my child's role and authorize documents or signatures for them. And the same for disabilities. So I can, somebody with a disability grants me that custodianship and I can switch to act on their behalf in my phone. What happens if people don't have a phone? Well, like I said, there is some cool tech coming out of people being able to sign with just a key card. Key card has a private key in it. This can work pretty well and pretty cost effectively. I've seen them out there for about 20 euros a card. One thing that's important, this can sign data, but it's pretty dumb. And what that means is that it doesn't know what it's signing and it can't actually store any data. All it can do is sign data. That means the data, so maybe your identity data, isn't stored here. Somebody else has to store it. So you do give custody away. So you do give your privacy away, but you don't necessarily give control. your private key on here still is the single source of truth of what you're doing in your life. There are a few other ways of doing that, a few other hardware devices out there. Be good to research this when the time came. What happens if there's no internet? Maybe you just live in a very remote area. So something we can do is basically build a reverse client. When I go up and maybe make a payment, I sign a document that needs to get broadcast to the network. I sign the document and I send that document to whoever I'm signing it to, maybe by Bluetooth, and they can put it on the internet. So my phone doesn't have internet, but whoever's I'm interacting with needs to have internet. The last case here, this is internet censorship. This may come from your internet service provider, or it could come at a political level from in the domain name system or something else. There are some cool solutions out there that basically do onion routing or Bluetooth routing or other routing that skirts around the internet to a point on the internet where they can access and go in. So I wouldn't say this is an easy thing to do, but it's definitely possible. That's it. That's kind of the end of the technical breakdown. As you guys know, the next section is going to be about who is it for and how we're going to make money and what's next. So I'll open up to questions now about the first half.
I have a question. If you go back to the timeline, yes, this one. So the the software as a service there. So like when I was being explained this the first couple of times, I was imagining that almost like how in Pomelo we put in what our grant should be and they kind of customize it and see where there's support for it. Would we have that sort of open input for folks who need whatever their service to be, or are we going to have like strictly defined, pre-engineered, pre-designed little basically packages that we deploy?
I think we'll offer packages of service. So this will be the Pro package. This will be the starter package. I'm going to show you what this looks like in some later slides as well. Maybe you can save your question for then.
Yeah. Also, you said that we don't need to hack one server, right? So because we will have all the data on our phone, but still we will have an issuer of credential, right? And this issuer, it will have a database, right? So what about those databases if
Yes.
they get hacked?
Yeah. So you're right. So the identity app itself is fully self-sovereign, but that doesn't mean all of the data in here is fully self-sovereign. So a university may issue your diploma. They're probably going to keep a copy of that, and somebody can still go to the university server and take a copy of it there.
Okay. Do we have any proposals here, like do not keep those copies on the in the, for example, university, and maybe just code it in the cloud, for example, like codify it and make them safe in the cloud, where only you have control of it.
Most likely, the university will be using the cloud already to host their data. What the university can do, what they will eventually be able to do, and this won't happen for the first few features, is that they will, in theory, be able to delete all of that data and trust that the data on the phone is the primary source, and that also has a backup. So they in theory can do this and remove that attack vector after we've finished building this.
Okay, another thing, so you create Tonomy ID, but how you will interact with the other organizations? So let's say you created this Tonomy ID. How you would interact with the universities, for example? What's your next step?
So it depends on the feature. I showed like this flow here. So this is for the login feature. The university would put a button that says login with Tonomy ID. right? For the transaction signing feature, maybe they want you to sign a transaction that proves, I don't know, you were at school yesterday. So what they'll do is they'll program on their website, which you're using, and you'll click, okay, prove I was here today. That'll redirect you somewhere, and it'll say to you, you're about to sign this transaction. The transaction is that I was at the university today. And then you'll see that on your phone, you'll click confirm.
So you are saying that we have to convince other platforms to program in our favor, to use our Tonomy ID.
Correct.
So
Yes.
we won't consider maybe to have a solution for them, so it will be easier to incorporate on other platforms, maybe.
Yes, that is part of. So what they will be using is the SDK, what we build. They'll be using this software that we provide to allow them to use that on their website and allow them to interact with the identity app.
Okay, so it means we are creating it, definitely, but they just only incorporate.
We won't create their app, but we'll create the way for them to interact with our identity app.
Okay, got it.
That'll be in the SDK.
I think I have my hand up first, Rebel. I'm not sure. I'll just go ahead. So if you could go back to the timeline again. I think I heard you say the MVP, the transaction signer, has already been either begun or completed. Where are we at with the transaction signer portion?
We are designing it, as you know, and we have built, let's say, the developer environment. So we've got a React Native boilerplate, we've got a demo app boilerplate, we've got a blockchain boilerplate. They all start running on our developer machines, and they all we can start hooking it all together in that way. But we haven't actually built the application yet. So we've just got this kind of developer environment that allows us to run it all at once.
Okay, and the transactions, have you defined sort of what those transactions are, a list of those transactions? Are they like smart contract transactions?
This is really defined by the application that integrates. Probably the main ones of interest for us will be what EOS, Telos, and Wax are doing, which is sending crypto payments.
Okay.
Okay, can you give one more real example of what we'll sign as a transaction signer? Like a real life, not the blockchain, like for normal people who doesn't get an idea about blockchain and everything. So how they will use it in real life?
So these guys on they don't even need to know it's on a blockchain when they're in Tonomy ID. So in none of this app does it even need to mention blockchain for them to get what's going on. We just say you're about to send 10 EOS to this person. Don't even need to mention blockchain. This will come out in the second half a lot more, who we're building this for. One of the users of this is going to be ourselves. We're building Tonomy governance, and you're going to sign a transaction that votes for a policy change. Another one, this would be a supply chain use case. You would sign a transaction that said, I handled this crate of bananas, and I'm sending it to Africa through DHL.
I think
Depends.
Rebel had a question. I think he's had his hand up.
Yes, I do. Can we go back to the Web 2, Web 3 slide? Yes. So all the data in Web 2 are saved in the database.
More or
and
less.
Web 3, it's saved in the client app. What happened if you lost a client?
Yeah, this is the big problem that Web3 is facing, is that there's no recovery. If you lose your client app, you lose your private key, you're fucked. So this is why we need to build better recovery mechanisms. It's a very specific reason why we have that feature, because it doesn't exist in Web3.
All right.
So, and we are solving it, right?
We're solving it 95%. There's definitely going to be cases where people still cannot recover with the 3 mechanisms we're proposing. And then I think we need to default back to the last recovery mechanism, which will be a custodial recovery mechanism. You do need to trust somebody to do it. Because if we're going to build for the mainstream, we have to build for 100%, not 95%.
Okay. But now, at least we are proposing a solution to recover the client.
Yes, that will solve a lot of the problems, but not all of them.
Okay, I have 2 more questions. What does it mean, MIT license, and how it will save your intellectual property?
An MIT license is almost the most permissive license you can put on software. So it means anyone can pretty much do anything they want with the software. It doesn't protect your intellectual property. It doesn't protect the software at all. Technically, even if you put an MIT license, you still own the intellectual property, but you're giving it away with the license. So you don't give away the intellectual property, but you give away the right to use it in any way at all. That's MIT. There are other licenses that allow you to give it away under certain conditions. You're allowed to use this, but only if you keep it open source. You're not allowed to take it and modify it and make it closed source. Or you're allowed to use this, but you have to give acknowledgement back to us. These are other types of licenses out there that should be part of the license review step.
Okay, and the last question for me, how we can trust you as a block producer that you won't change my data, like my entire data, and just change all the blocks if you control the majority of the block producers?
If you control the majority of the block producers, it can then be possible to modify what's going on. This is why you typically have a decentralized network where lots of people are running the blockchain, so that you don't have to trust one person or one entity to run that node. And the reason that is because every node in the network, every server, is in real time cryptographically auditing every other node. What that means is they're checking the other nodes, say they have the data that everyone else has, and they do that in a way that keeps everybody mathematically accountable to each other in a mathematically provable way.
Okay, as I understand, so you will have your own network of the block producers, right? How you will give them permission, like how you will choose who will be who? Maybe, some company will try to Sybil attack you, so how you will choose different block producers?
That is a question for each ecosystem to decide. The question is who will run this network. Previously, the previous architecture here, before blockchain existed, one entity had to run the data layer. There was no other way of doing it. With blockchain, multiple parties can be entrusted at the same permission level to run that data layer. And who that is decided by the ecosystem. Maybe we decide it's going to be these 5 companies. Maybe we decide it's going to be the government and these 2 companies. Maybe we decide it's just going to be whoever the wealthiest is. So it's more than just who. You can also program rules in to say who it is. For Telos and EOS, they've made a system where the people who run the blockchain are those who are voted in based on weight of how much crypto you have. So if I have 10 EOS, I can vote 10 times heavier on who the block producers should be compared to somebody who has 1 EOS.
Okay, thanks, Jack. It was a pretty wonderful presentation.
Nice. Shall we have a 5-minute break?
Yep.
Cool. Cool. So who is this for? So with the Tonomy ID product, we've identified 4 kind of main first users. The first, as I think you guys know, is the EOSAO, existing EOSAO community. And there are three main public blockchains and public cryptos in there that are quite interested in this kind of tech already. So this is a community of investors and tech enthusiasts. What we will do is Tonomy. We will launch the service of EOS ID or Telos ID or Wax ID. And the idea with this as users is we get publicity through them for our amazing tech. And that also gives us access to grants within that ecosystem. And there's quite a few grants. So this is a end user target here. We're actually going to be launching the service for the end users. The other place we're looking at is other Web3 communities who are looking for a better identity and blockchain service out there. And this is where we offer software as a service to them. We can also white label our identity app for them, and they can launch and get all of that as part of our package. The third is industry, not necessarily in Web3 already. This is again where we offer our software as a service package to them, and they can basically build whatever the app they want. It doesn't even have to be in Web3, but of course we have some Web3 components as part of ours. And the last is a first-hand use case. That means we're going to use this when we build Tonomy Gov and Tonomy DAO. So this is not going to happen immediately. We have to build those first, of course. But this is, of course, our end goal. This is the big, hairy, audacious goal, is to build all of this stuff. So you can see here we've got third-hand usage and first-hand usage. And we're going to be building for end users as well as developers who integrate with this, right? So I'm going to deep dive into all of these now. So the first is the EOSAO ecosystem. And I'm going to give you guys a lowdown on what the hell is going on in this place, because it's a bit complex and incredibly interesting. So what happened was about in 2018, a company called B1, made up of a really innovative guy, Dan Larimer, and a business guy, Brendan Bloomer, created this company and did the largest ICO to date, $4 billion in their ICO. And from that ICO, they developed a software called EOSCO. This is a blockchain protocol software, okay? And at the end of that ICO ran on for 1 year. On the last day of the ICO, the EOS blockchain was launched. So this is the first blockchain that's run on this protocol. And everyone was pretty happy at that point. People started realizing the innovation, how much better this software was compared to Ethereum and a lot of other second generation blockchain protocol solutions there were. It had a lot of really good things. It solved a lot of problems. It's just really good. And in fact, to this day, the EOSAO software repository is the third most liked blockchain by developers out there, by the number of forks and stars and stuff. That's after Bitcoin and Ethereum. EOSAO is the third highest, higher than Hyperledger and Parity and everything else. So they launched the EOS blockchain. But people started to see that this EOSAO software was actually quite flexible in its governance model. And some people didn't quite like the EOS governance model. It's called delegated proof of stake. And it basically gives whoever has tokens the power to vote with those tokens of who the block producers should be. There's some subtle nuances here, but a few people didn't like this. So soon after, the Telos blockchain was launched, running the same protocol, but a different governance model. This was launched by the Tonomy Foundation. Okay? And not long after that, the Worldwide Assets Exchange, WAX, was launched as well. Again, a different governance model running on the same protocol. Fast forward a few years, and there are problems in EOS and Block 1. EOS is having governance problem, and Block 1 is starting to really diverge away from maintaining this software, EOSAO. So what happens is Dan Larimer quits. It's a big event. Everyone's like, holy shit, EOS price plummeted. The main CTO managing this leaves. This company is now pursuing quite different interests not related to EOSAO anymore. And their $4 billion ICO they still own. But Dan Larimer didn't leave. He joined a company called Fractally and started basically trying to improve the governance model on EOS. That managed to succeed quite well. Basically, a new entity was democratically elected by the EOS community called the EOS Network Foundation. So this is a legally registered company, I think, in Canada. This was elected on, and there is a board and all of this stuff. And they were decided to preside over EOS and help maintain the blockchain's health and basically remove the dependence on having B1 as a maintainer of the software. So Dan started joining this team, which proposed to create the next version of EOS.io called Mandel. So this is the next release of EOS.io. They're distancing the brand from Block 1. And this will be used to power all three of these blockchains. Another thing that happened was these three blockchains and another one, the UX network, also powered by EOS.io, banded together and created the EOS.io coalition. So this is supposed to represent the collective interest of all of these blockchains powered by this one software, which will very soon be ported to a new name and a new version. This is going to be Mandel version 3. It's probably going to be running on EOS in the next month, I'd say. So all of these blockchains actually have different grant proposals, different foundations running them. Some of them don't even have a foundation, like Wax. Very interesting to see. And all of them have now basically cut all ties to Block 1, the original creators of the software they're using. So this is kind of the ecosystem of EOS.io and these three main chains, what's going on. They're still using this very powerful software. Wax is, in fact, the most used blockchain in the world. Most used in that there are the most transactions happening on it on any chain in the world at the moment. So in the EOS.io market, we already went through this. This is kind of the identity wallet market in EOS.io. And there's not much out there. The main one that really works is Anchor. This is what everyone's using. There's a few others. They've been depreciated or they're not open source. So this is the main one, and we're aiming to be probably the next big one in the space. So it's a very unsaturated market. There is a lot of room for better solutions out there. So like I said, we're kind of building this for these three blockchains. We haven't really figured out exactly who yet. They all have different funding in different forms. There's the EOS Network Foundation, which has its own grant process. The Telos Foundation also has a grant process. And all of them have their own on-chain crypto version of a funding mechanism. So this is done by the actual users of the blockchain voting for which works should be happening, and that's all automated on the blockchain. So for these three chains, these are kind of the major upgrades we provide compared to mostly the Anchor wallet. So we provide a slightly easier to use wallet. Ours is open source, unlike Anchor. Once we have the credential sharing feature, you'll be able to privately share your identity data, and that identity data does not need to live on the blockchain, which is illegal. With our recovery features, people will be able to recover their wallet if they lose their phone, which is the problem that Rebel pointed out. We have a high scalability than one of the most popular Wax wallets out there, and better security. We'll be able to share data directly peer-to-peer, which opens up the possibility for decentralized KYC and Sybil proof, which they're all quite interested in. And lastly, because of the W3C standards that we use in the credentials, it makes all of the data in our wallet actually interoperable with all of the rest of the SSI ecosystem. That SSI ecosystem is being heavily invested in by major state nations like the US, Canada, and the European Union, and big enterprises like IBM and Microsoft are all putting a lot of effort into SSI. So it's really looking like that's going to be the way forward. The European Union has just approved more or less an SSI app for all of the member states. And the did method has just been moved up from a draft to a recommendation that just happened last week, signifying that this is really likely to become a new internet approved standard. So like we said, we will probably launch these identity apps white labeled for them, and they'll be then used by the end users. These end users are investors of these cryptocurrencies and tech enthusiasts. So people who own Telos, EOS, and WAX. These are 3 cryptocurrencies. People who are really into the whole crypto investing and speculation scene. And then they're also really interested in technology. Our main target here will be the users, because they control these networks, and the app operators in these networks. So applications that run on Telos, applications that run on EOS, applications that run on WAX, convincing them to integrate our app and allowing users to sign in and sign transactions on their app with our identity app. So there are lots of other people out there building other Web3 stuff, not on EOS.io. And they're coming into certainly many struggles. One of them is in identity. The first step people have to make to sign a transaction on Ethereum or any of the other public blockchains out there is they have to sign it from somewhere that's secure, that's also usable. And that's where we come in. People coming up against that problem are people we can help, and they can come to our platform. The idea is to offer a service to them that we basically launch our application for them, and then they can use that to sign into applications. So a good example of that would be, for example, ChefChain. They were using Komodo. They don't like that anymore. They want to try our way out, and they can click, and now users can sign in with the ChefChain ID, perhaps, and they can sign a recipe on the blockchain. That's ChefChain. Or perhaps EnergyWeb. They're currently using Ethereum, but once they've used our product, they'll sign in with the EnergyWeb ID, and they'll be able to click and sell energy to the person down the road, whatever their use case is. So a lot of these advantages here come not necessarily from the identity product, but from the protocol that we're using, this EOS.io protocol. It's very good. But certainly some of it comes from the identity app, and it's because it's going to be more usable. It's going to be open source. We're going to have these private credentials that aren't stored on the blockchain, stuff you've seen here before. A few different things are the cost. So the use of our blockchain technology will have a much lower cost, both in crypto fees and environmental impact. It's very low carbon footprint. The developer experience is much easier, developing usable apps. And then there's better legal compliance with this as well. So now that you have that in mind, I want to kind of introduce to you what this software as a service system will look like. You'll go onto a website, there'll be a page that kind of looks a little bit like this. And there's basically 2 ways for people to consume our service. One is where they self-host it themselves. That means they take our open source software that anyone can view and run it themselves. The second is that we run it for them. This is the software as a service model, and the other is the self-hosted model where we provide support. So again, it's in packages. These aren't fully figured out. We also need to figure out the license to make this make sense for us. But the first option is just they can do it for free. Of course, it's open source. They just need to figure it all out. Maybe there's some community forums they can look at, but they can just do this. We can't stop them because it's open source. But of course, they may want some support in doing this. So they can still run it themselves, but we offer them a priority support for small teams, and we do them at some fee. Need to figure this out. Or maybe they want a much more assistive, where we actually talk to them about technical strategy, scaling, other kinds of things. They can reach out to us on that. So all of these software systems, they come with our user-friendly identity app, a fully sovereign security model of that identity app that promises that those keys never leave that phone, that you have full sovereign control of those keys. And that's important for these people who are using this service to understand. So that's the big security use case for them. It solves compliance issues, it solves security issues. And I think on this side, it can show some of our features. So this is our first feature. It shows our second feature and says coming soon. This kind of generates some interest. They're going to have some more features coming soon as well. The other model is the software as a service. So again, you get all of this. And in this case, we actually deploy a blockchain node, an EOSAO blockchain node that's connected to a white labeled app. So this will be, they'll click here, start. They'll put in maybe their name and a few branding colors, and we will give them an APK and an IPA file. And with those, they can actually deploy those to the Google and Apple Store and know that those files will be able to connect to the blockchain node that we run for them, right? So this is the starter. A more professional one, this would be much more production ready with some redundancy of the block producers and a more scalable set of tooling for them. And again, sort of an enterprise option. Pricing isn't figured out. We'd price this based on, whatever made the most sense for our infrastructure costs for doing something like this. So now we have the software as a service model a bit more in our mind. This is kind of what we would look, the kind of thing we would look for our third use case, which is for Web 2, our industry use case. This is people who are not currently using Web 3. So we can offer them sovereign keys. So keys only stored in the client. That means they just can't be hacked. You get the guarantee that whoever has the key signed the data. This is a better security model. There's no server-side security risks. There's much better privacy. That also means that there's a lot that there is data privacy compliance by default. It means you comply with GDPR by default, or the Californian Data Protection Act by default. You don't actually need to put any effort into compliance. That takes a lot of work out of the way and a lot of security and compliance costs and risks out of the way. Of course, it's open source. That's important because a lot of identity solutions aren't open source. That brings the trust. Like I said, these W3C credentials are highly interoperable and reusable. That means users don't need to fill out the form over and over again, or create their data over and over again. It can be reused. Because this data is shared directly from me to you without having to have a third party involved, it's more scalable because you don't have to have an infrastructure for that third party. So you just scale system more. It takes out legal frictions due to the need for legal frameworks to have to check the signature and stuff like this. So having to check written signatures costs a lot more than having to check a signature that came from the device that the person was in. If you already have that down packed, it just costs less. These are the kind of legal frictions we remove. And of course, because our public keys are on this decentralized network, there's no single point of failure. Everyone can continue using the system, even if one of the blockchain nodes goes down or somebody attacks it. So just to give a few ideas where this could work, we could go to Walmart. They might have a client-facing application where people can do track and trace of the products that they're selling. Or this could be an internal tool for Walmart where their employees are signing off on receiving the food products that they get in store or in their logistics chain. It could be for Airbnb, right? It could be to sign into Airbnb and to prove that you are the one who's the owner of the property and that you're receiving payments automatically within the site. It could also be an app like Corona Check. This is what we use in the Netherlands, and I have a certificate in here proving my vaccination. That vaccination could all be done in W3C credentials, which I can share to somebody else without them needing to go to the government every time to check that it's valid. That's the big thing we can do for them. So that everyone's clear, there are drawbacks, of course, and I want to make sure everyone gets a few ideas of some of these. Some of these are related to blockchain in general, and some's just related to new tech. So the first one is scalability. EOSCO scales almost one of the best compared to other blockchains for the security model it gives. It gives a security model that says every node cryptographically audits every other node. There are some other blockchains that scale higher, but they don't have that feature anymore. They don't give that proof that every node checks every other node. So it can do approximately 4,000 transactions per second. A database can do hundreds of thousands of transactions per second. So it just doesn't scale as well. And we probably won't see that for most apps, but if you start getting millions of users, we might start seeing that threshold being hit. This is a highly advanced new tech, and with that comes complexity. And with that complexity makes it harder to find developers and pay developers the right amount for that niche knowledge. So that increase time to build stuff and cost to build stuff for people who want to use Tonomy ID. We can minimize this as much as we want, but it will still be a small to medium factor. For us, we will make it as small as possible. For applications, they need to know this is a reality with using all of these new crypto systems. If you're out there talking to people about this, people will probably eventually ask about Ethereum. Ethereum's the biggest blockchain technology and crypto ecosystem out there. Their tech's just not as good. It's just quite outdated now in the scheme of things. But they do have that bigger ecosystem, a lot bigger, and that attracts more developers and has more developer tools. So things are easier at the beginning, but to build proper applications, it gets harder quickly. And the other thing I want to mention here is that the EOSCO protocol now supports Ethereum smart contracts. So we can actually migrate people from Ethereum to our EOSCO ecosystem without them having to change all of their smart contract code necessarily. So that's actually quite useful if people are already in Ethereum, which a lot are. So what's next? Let's say we build Tonomy ID. What do we do then? Well, we need to start selling Tonomy ID. We need to try and make some money off it. We need to prove that it's working. We want to build the software as a service platform and our other platforms. And of course, the Tonomy ID story never really stops. It's a cycle. We just continue to learn and iterate and cater to the user's needs as we see needed. That's it. That's the end of the slide. So we can have questions now about all of it.
Awesome. Let's first give a I liked it a lot. I had some technical question. Since there are smart contracts being implemented, you said there were about 4,000 transactions per second that EOSCO can handle. Do you know if they're going to implement ZK rollups or optimistic rollups?
So the new version of Mandel now has the crypto primitives to do zero knowledge proofs, which means that is now something that's possible on EOSCO. The need for ZK rollups is not nearly as dire as it is on Ethereum, which is where they're doing them, because Ethereum scales to 10 transactions per second, and EOSCO is already at 4,000 or so. So it's just a lower priority, let's say, but it can be done technically now, and maybe will be done.
Cool. Awesome.
They're more looking into keeping things simple and not making too much cryptography. And so I think their priority is more on getting into blockchain communication sorted and then having a multi-chain ecosystem that's all connected together.
You've worked with the EOS Foundation before, right?
How needed do you think our technologies are to them?
I've worked with Block One before. I've worked with the Telos Foundation before, and the Telos ecosystem before, and generally am known in this space. I think something like this is going to be quite well received. Mainly the usability aspect of it is going to be very well received.
Yeah, the last part. The social accountability.
No. I just mean that you can sign transactions without needing to know anything about blockchain or crypto, which is the aim for this app.
Right.
I think that in itself, which is already in our MVP, will be, I think, quite useful for them. Right now, the main solution, Anchor is difficult to use, and people complain about that. To get your first account is quite hard.
Cool. Yeah, so that's a question I actually also put on the Rocket chat because I didn't want to interrupt the thing later on. The prototype that you have made right now, can we already test this?
Which prototype?
The Figma prototype.
No. Oh, this thing?
Yeah.
No, because this was really made to educate you guys into a less abstract version of what the hell Tonomy is going to do. It's not really the actual app design.
Okay.
And that's what Kerry's going to be doing now.
Right.
So after Kerry's...
I do want to do significant user testing on it. Yeah, Kerry is in another meet as well, so I don't know how well.
That is the plan, Chris. Absolutely. Once Kerry's done this next version, we're going to give it to some close friends and get them to test it. Once we get to the high fidelity design, we actually do some real user testing with some real users.
Would you like me to attract students to do that?
To do what?
Testing.
Yeah.
Let's finish with questions, maybe.
Okay, no, you're not asking questions, so I'll keep on asking questions.
Yeah, if we finished, that means we need to stop recording because the Jack, will cut and edit a lot.
I agree.
Someone else.
Yeah, so let's finish all the questions about the content, and then we can talk about this kind of stuff.
Sure. Any more questions there?
From my side, I don't know because it got me by surprise how well and how to say easier presentation is. So very good.
Thank you.
Yeah. Also, hats off to you again, Jack. You're doing very well.
Very well.
Do you have any
Awesome.
questions on the?
You are killing it, Jack.
Any other questions? Otherwise, I'll stop the...
Ball, do you have questions?
I don't.
Okay, then I'm going to stop this here.
All right. Oh, Stefan is already gone.